Hello friends. So today's agenda is algebra 3, in which mainly we'll be covering inequations. Okay. I hope you have completely watched the videos of algebra 1 and algebra 2 properly. In algebra 1 it was all about linear equations. Okay. And algebra 2 everything was about quadratic equations, and some part of it was polynomials. All right. So let's see what is inequations. Inequality, as the name suggests, not equal, right? Not equal means you will have symbols like this: less than, more than, less than or equal to, more than or equal to. So mathematical expressions involving these four symbols mainly are called as inequations. Yeah, so we have these four inequality symbols. All right. Okay. So we'll be studying these inequalities under linear type. Then we will see quadratic and higher order together. Okay. And later on we will take this to modulus also, modulus inequalities, inequalities involving modulus. So let us first start with linear inequalities. I hope the word linear is now very comfortable for you. Okay. All right. Linear means whatever variables are involved, highest power will always be 1, isn't it? Highest power 1. Yeah, when there was equal to sign we used to call it as linear equations. Yeah, now let's understand how do we behave, or how do we go about solving linear inequations. Solving means majorly those mathematical operations which we used to do in linear equations, that is addition, subtraction, multiplication, division. Let's see, if you perform these operations on linear inequations, then how to go about it? Is it like same as the way we used to do in linear equations, or is there any change here? Let's see. So first we need to set a context. Suppose x and y, there are two variables, highest power is 1, hence linear. If x is more than y, under this context I'm understanding how to behave about addition, subtraction, multiplication, division, and one more, reciprocals. So if we add same quantity on both sides, inequality doesn't change actually. Logical, right? Whatever thing was, there are two non-equal things, unequal things, higher and lower. If we add same thing to both of them, so level will go by the both of them will go up by the same level, right? Isn't it? So it doesn't depend on a. The inequality still holds true. There is no need of any changes. Similarly for subtraction also, no change. This was a level, subtract same thing from both, it will go down. Okay, so higher one will still remain higher and lower one will still remain lower. Means adding or subtracting any quantity doesn't affect the inequality symbol. So we can also say inequalities are additive in nature. All right, you can easily verify these things with the help of some numbers. Yeah, so for example 10 is more than 6. Now if I add 2 on both sides, so 12 and 8, of course 12 is still bigger, right? I hope everybody is comfortable with these symbols. When I write this side should be bigger quantity and this side should be smaller quantity, right? And when we write like this, mouth closed, mouth open, something like that, you have studied in school, right? Smaller quantity here and bigger quantity this side. So whether I write this way or this way, both are same, both are correct. Huh? Don't feel that I changed the inequality symbol. Both are correct. Adding 2 on both sides, so 8, and then this is 12. 8 is still less than 12. So inequality symbol did not change. And you can think reverse from this. If 12 is more than 8, subtract 2 on both sides, you'll get 10 more than 6. So inequality did not change. Same with this. So addition, subtraction are like two very comfortable operations. The way we used to behave in case of equations, same behavior is there in case of inequations also. All right. Let's see what about multiplication. So same example, 10 more than 6. If I multiply by 2 on both sides, so 20 and 12. Wow. So 20 is more than 12. No change. It means no change. Inequality symbol did not change. But hold on. I just multiply with positive 2, right? What if I multiply by negative 2? So 10 more than 6, negative 2. So minus 20 and negative 12. Now which one is bigger? Come on. What do you feel? Which one is bigger? Yes. Now minus 12 is bigger. Of course. What does this mean? Here inequality symbol changed. Means this is the point to be careful about. If you multiply by a positive quantity, the inequality symbol is retained. There is no change. But if you multiply by negative, of course, it changes. That is what you saw just now. So a quantity which is higher in positive, if you multiply by negative, it will become lower, na, logically. Yeah. It's like 6 and 10. Both were on the right side of origin. So 6 was lesser than 10. If I make them negative, suppose you multiply by minus 1. So minus 6 and minus 10. Mirror image, right? Now minus 6 is closer to origin. So of course minus 6 is bigger than minus 10. Here 6 was lesser than 10. Okay, I hope you understood here. So in case of multiplication, we need to be very, very careful about. So basically, and same goes for division actually. Yeah, multiplication and division logically are one and the same thing, right? So see, 20 more than 12 divide by 2. 10 more than 6. So more than inequality sign was retained, no change, because I divided by positive 2. Check this, minus 20 is less than minus 12, isn't it? Divide both sides by minus 2. Yes, so we get 10 and that side it is 6. So 10 more than 6. So less than became more than. So inequality flipped because we divided by negative quantity. See, divide by 2 is as good as multiplying by 1 by 2. Dividing by minus 2 is as good as multiplying by negative 1 by 2. So multiplication and division will behave in the same manner, the way we saw for addition subtraction here. Okay. Adding 2, you can say subtracting minus 2. Yeah, subtracting 2, or you can say it as adding minus 2. One and the same thing, different ways of saying the same thing. Okay. Thank you. I hope you're understanding. Yeah. So x more than y. What about ax and ay? In between them, same symbol will be retained if a is positive. Same goes for x upon a and y upon a, isn't it? And if a is negative, simple. I hope you must have guessed it. Inequality sign will, yes, change. Whatever the relation is originally, uska ulta. All right. So comfortable till here. Addition, subtraction, multiplication, division. Okay. Now, one more operation, friends, which will be quite useful in solving so many questions. Reciprocal. Taking reciprocal. Let's first experiment with numbers. Let's say 10 and 5. So 10 is more than 5, right? If I take reciprocal 1 over 10 and 1 over 5. Of course. Now 1 over 5 is bigger than 1 over 10, right? Logically you can say percentage wise also 1 by 5 is 20%, 1 by 10 is 10%. In terms of decimal also you can think 1 over 10 is 0.1 and 1 over 5 is 0.2. So 0.2 is bigger than 0.1. Now you can visualize the number line. So here, what is the conclusion? In this situation, inequality sign flipped. Let's take, see, explore all possibilities. Huh? Here I took both of them as positive. One big thing to be noted, whenever you're trying with numbers, if you don't have any clue regarding any specific property, if you're experimenting with numbers, please try and explore all possible cases. Don't miss out any one particular case. That is the main challenge. Okay. Now, minus 5 is bigger than minus 10, isn't it? I am taking reciprocal. Minus 1 by 5, minus 1 by 10. Now which is bigger, friends? Negative hai. Minus 0.2 and minus 0.1. What do you feel? If you visualize number line, Yes, first you will get minus 0.1, right? And then you will get minus 0.2. So minus 0.1 is bigger. Means minus 1 over 10 is bigger than minus 1 over 5. Here also I equality sign flipped. So you might now conclude that whenever we take reciprocal, the original inequality symbol reverses, isn't it? Hold on. Did we explore all cases? No, right? What about one positive number and one negative number? Effortless thinking actually. So 10 is more than minus 5 by default, obviously. If I take reciprocal 1 by 10 and minus 1 by 5, what do you feel? In this case, yes, common sense, right? No need to even think about any calculation, visualize number like nothing. This is still positive and this is still negative. So positive has to be bigger than negative, isn't it? So what's the conclusion here? Inequality symbol did not change. This is what we call it as exploring all possible cases, friends. All possible cases. So that is why we need to mention this. If both x and y are positive or both are negative, means both x and y are of same sign, then you can flip the negative, the inequality sign. Yeah, check. If they are of opposite sign, of course, inequality symbol stays the same. Understood? Yes. So adding, subtracting, clear. Multiplying, dividing, very clear. There you need to be careful, especially if you multiply or divide by negative. Inequality symbol reverses, right? And finally, while taking reciprocal, it reverses if both x and y, both sides you have same symbol quantities. That is both positive or both negative. All right. See this. Okay. Cool. One more variation, friends. Something about squarings. I'll take it with numbers. For example, if x is more than, let's say, 2 but less than 5, if this is the situation, so if I square it, what will be the lower limit of x and upper limit? So this is lower limit, this is what is upper limit, right? Simple, right? So x square will be more than 4 but less than 25. Very comfortable. Yeah. Okay, here when both were positive, very comfortable. Now, if both are negative, then also you see if x is more than minus 5 but less than minus 2. So if you square, of course, negative ones will get converted to positive values. But after squaring, minus 2 square 4 will become lesser, na? And minus 5 square 25 will be the higher number. So x square will be in this range. I hope you're getting it. Now, see this third one carefully. Let's say if x is more than minus 5 but less than 2, means lower limit is negative, upper limit is positive. So we have opposite symbols here. So can you simply say x square will be like more than 4 but less than 25? Will this work here also? No. Think about it. No. If you visualize number line, x is any number between minus 5 and 2. I hope you know what is the lowest square by default. Means what is the lowest possible answer of any square? Yes, 0, isn't it? We write like this. No, whenever you square any number, any real number, the minimum value is 0. Don't say that square is always positive. So it is 0 or positive. That is definitely not negative. We have 0 also in this range present. So after squaring all these numbers, don't you feel lowest number will be 0 by default? Yeah, so lower limit is 0 by default. I'm putting equal to also, so because 0 is a part of that range. So after squaring 0, I'll get 0. And that will be the lowest value of the square, x square. And highest is still less than 25. See, if original inequality gives you equal to sign there, the way, suppose if I take, say, minus 5 less than equal to x less than equal to 2, then after squaring, less than equal to minus 2, sorry. Yeah. Then you can write equal to sign here also, right? Simple. Here in the original thing only I did not give you equal to, that is why here also equal to sign will not come. That is easy, right? Okay. So here, since 0 is a part of this range, so x can be equal to 0. So after squaring, x square will be equal to 0. That will be the lowest value, and highest is just below 25. So just be careful about this third case. This is our wow part. Okay, cool. One more thing, friends, one more thing. Interval notation. Sometimes they will give you the options in some different style. You should be careful and comfortable about this. So for example, if x is between 2 and 5, between, that is more than 2 but less than 5, you can also write it in terms of interval notation as x belongs to the interval 2 comma 5. 2 comma 5 means lower limit is 2, upper limit is 5. In between 2 and 5, all the numbers are allowed, but extremities are not allowed. Means x can't be equal to 2, x can't be equal to 5. So we put this kind of bracket, and if we have equal to sign allowed, then it is like this: x belongs to 2 comma 5, rectangular bracket. Okay, rectangular bracket. All right. So sometimes you have equal to sign at one place and not there at the other end. So you can just mix and match these brackets. So add 2 rectangular bracket, add 5 open bracket, small bracket accordingly, right? This is also called as open interval since both the endpoints are not included. So open on both the ends. This is also called as closed interval, closed at both the ends because both the endpoints are allowed, included. And this is some half open, half closed. So you can also order semi-open, semi-closed, or there's one more word, clopen. Yeah. I hope on the number line also you could visualize 2 is not allowed, 5 is not allowed in the first case. Everything in between is allowed. In second case, 2 was allowed, 5 was allowed, everything in between is allowed. So 2 was allowed means just represent it like this. Shade it darkly, dark shade, tickly kind of thing. Okay. And here 2 is allowed, but 5 is not allowed. All right. I hope you understood this as well. All right. Thank you. Next one is quadratic inequations. Now, when the term quadratic is there, I hope you're very, very clear about it that the highest power of the variable used will be now 2, degree 2, right? Something like this. X square more than 25. Yeah, how to go about this? Will you do it like this, the way we do in case of equations, that x is equal to plus minus 5? ऐसा होता था? Then whatever the symbol is, I'll just copy it as it is. This is very, very casual approach, and this is of course wrong. This thinking will not work here. X is more than 5 also and more than minus 5 also. This is as good as x is more than 5 only, na? Because if x is more than 5, automatically it is more than minus 5, isn't it? So it doesn't work this way here. So let's understand how to deal with this. Now, to deal with this, we have a nice method which can also take care of higher order also. That is cubic and beyond. Something called as wavy curve method. Okay, wavy curve method. Now, what is this method? There are a few standard steps. Step 1, ensure that RHS is 0. Okay, so I will ensure. So x square minus 25 more than 0. So I subtracted 25. Did you see? I did not change the inequality sign. Yes, I did not change the inequality sign because I subtracted 25. Subtraction doesn't affect inequality sign. Inequalities are additive or subtractive in nature. Okay. Step 2, ensure LHS is in factorized form. I hope you are comfortable with this word. Factorized form means what? Multiplication or division form, right? Here, as of now, if you see left hand side, it is not in factorized form. Let me factorize, and here it is possible. A square minus b square structure, you can see. So a minus b into a plus b. Yes. So step 2 sorted. Step 3, ensure coefficient of x or whatever the variable is positive. So ensure coefficient of variable is positive. So here I checked, both the x's are having positive coefficients. If not, we will multiply by -1 on both sides and make it positive. But just remember, if you're multiplying by -1, inequality sign will change, isn't it? Because I'm multiplying by negative. So earlier learnings will be used, obviously. Step 4, plot the roots or the critical points, whatever you can say, it's okay. Plot the roots or critical points. Roots, I hope now everybody should be very, very comfortable. We had discussed so many times. I'll repeat once again. Those values of x for which y is 0. Okay? Those values of x for which y is 0. So here, if I want to make it 0, see, this whole thing is left hand side mein jo bhi dikh raha hai na, that is y only. Function of x minus y into x plus 5. When will this be 0? Mentally just equate each term to 0. So x minus 5 equal to 0, so x is 5, right? So I got first root. X plus 5 is equal to 0, so I got the second root, x equal to minus 5. And you plot it the way they appear on the number line. Okay, all right, very easy. Now last step. If first 4 steps are sorted, fifth step will flow easily. Can you see my number line got divided into 3 regions, 3 zones? Which 3 regions? This is the first region where all the values of x are right side of 5. To the right side of 5 means they are more than 5, isn't it? Second region, yes, between -5 and 5. Third region, to the left of -5. Left of -5 means less than -5, isn't it? All right. So let's see how will this entire expression, that is x minus 5 into x plus 5, behave in these 3 regions. So in the first sum, I'll explain in full detail. Then second sum onwards, we'll have a shortcut. Now, if I choose any value to the right side of 5, to the right side of 5 means x is more than 5. Substitute the value of x which is more than 5, let's say 6 or just 5.1 also, whatever. Don't you feel x minus 5 and x plus 5, both of them will give you a positive answer? Don't worry about the value, just understand the sign of that value. Both of them will be positive. Yeah. Make a bigger number than 5 minus 5 will ultimately be a positive value, isn't it? So both the brackets will give me a positive answer. Product of two positive quantities is positive. So I am writing plus sign on this region. In this interval, all the answers of that function or that y will be positive. Okay, if you take x as more than 5. Okay, so if your input is more than 5, your output will definitely be positive. Let's check in the second region, that is between -5 and 5. I'm sure you smart people must have guessed it already. If I take a value less than 5, so x minus 5, what do you feel? X is less than 5, let's say 4.9 or just say 4. So 4 minus 5, I'll get negative answer or not? X plus 5 will still be positive, but x minus 5 will give me a negative value. So negative into positive. Yes, ultimately it will be a negative answer, isn't it? Correct. So in the first region, both of them were positive. In second region, one negative and one positive. Let's go to the third region, to the left of -5. Let's say -6. Take x equal to -6. Substitute in both the brackets, -6 minus 5 -11, -6 plus 5 -1. Both of them are giving me negative outputs, negative values. But there are two negative values. Hold on, there are two negative values and you are multiplying them. So negative into negative, of course, positive, right? So two negatives is as good as positive only, friends, isn't it? So did you see the planning now? It will always start with positive number, positive answer be positive in the beginning? Yeah, obviously throughout also in real life, because you are taking a value which is higher than the highest number in all the values, because when you plot all the roots, the rightmost root will be biggest number, right? So if you take a number bigger than that also, so all the terms will give you positive answer. And the moment you shift to the second region, one term will become negative, for sure. Yeah, and rest all will be positive. Then if you keep moving to the left side by one region, number of negative terms will increase by one. So one negative, then two negatives means positive, then three negatives, negative, then four negatives means positive. Yeah, so rightmost interval will carry positive sign. I can see for sure if I have followed the first four steps, will always carry positive sign. And then minus plus alternately. These are the 5 steps of this superb method called as wavy curve method. All right, suppose if there were like 4 brackets, so 4 roots. So overall 5 regions, right? With plus, minus, plus, minus, plus. That's it. This is sorted if first 3 steps, first 4 steps are sorted, especially first 3. Okay. In step 4, we just plot the roots, right? Understood? All right. So let's complete this particular question. I wanted the answer to be more than 0. More than 0 means positive. So where all I am getting the positive answer, this one and this one. So how should I write the answer? X should be less than minus 5. In the original inequation, there is no equal to. So I am not writing equal to. And here, this one is X more than 5. In between, how should I connect them? Should I write or and? Of course, or, right? Because both of them cannot be possible together. X can either be less than minus 5 or it can be more than 5, right? You can't have a number which will satisfy both the things at the same time. Impossible, right? Yeah. Or now I have interval notation also, right? Come on, negative infinity se leke minus 5 tak, but minus 5 is not allowed, and of course infinity is never allowed. We don't know what is the value of infinity exactly. It is beyond imagination. Or means union 5 onwards till infinity. So this is your wavy curve method for solving quadratic inequations or higher order inequations. Remember this. All right. Now in this one, first step, x square minus 25 less than 0, ensure RHS is 0, factorize. Yeah, then coefficient of variable positive, yes. Then plot the roots. What? Minus 5 and plus 5. Rightmost interval will always carry positive sign, then negative, then positive. Yes, and what do I want? Less than 0 means negative, means this is my answer. So x should be less than 5, and at the same time it can be more than minus 5 also. X less than 5 means to the left of 5. X more than minus 5 means to the right side of 5, minus 5. Sorry. So this is the common region, right? Common is there. That is why I can think of and. So this is how we will write a closed interval between these two numbers. Or you can also say x belongs to minus 5 comma 5, and bracket will be like this because equality is not there. I hope you understood. What about this? Same way, first step is sorted. Second step, you will factorize, and then coefficient of x should be positive, and then plot the roots. So ultimately roots. Now you can do shortcut also, at least for quadratic. So here the roots are what? Product should be minus 6, sum should be minus 1. So yes, minus 3 and 2, change the sign, 3 and minus 2. Remember shortcut? So minus 2 and 3, then you know plus, minus, plus, and you know you need negative answer. So x should be less than 3 but more than minus 2. Okay. And interval style, minus 2 comma 3, round bracket, small bracket. Okay. Higher order. So higher order, you see, so here power goes beyond 2. there are 5 brackets. So x raised to 5. Now it will go up to x raised to 5. If you see, the good thing here is what? Step 1 sorted, RH is 0. Step 2 also sorted. Left hand side is in the factorized form. Correct? Step 3, check coefficient of x throughout. It is positive. First 3 steps are straight away sorted, friends. Then you just have to plot the roots. Step 4. How will you plot the roots? Equate every term to 0 and get the value of x. That is the root. So 2, 5, 7, 10, 15. Then you know what to do. Plus, rightmost with plus, minus, plus alternately. And we want more than 0 means all the tick ones will be the answer. So x should be between 2 and 5 or between 7 and 10 or more than 15. Understood? Okay. You can also write it as interval style between 2 and 5 or this union between 7 and 10 or 15 onwards up to infinity. I hope you are comfortable in both the notations, right? Okay. In this case, same thing. First 3 steps are sorted. I hope you can check. Then plot the roots, equate every term to 0 and plot it the way they appear on the number line, right? -9, -1, -9 from this, -1 from this, then 6, 12, 15 in that order. Then you know what to do. Plus, minus, plus, minus, plus, minus. Less than 0. So all the tick ones are the answer, right? I'm sure you understand how to write in both the ways, both the manners. Okay. Now, what if suppose it was like this x plus 1 into x minus 6 into x plus 9 over x minus 12 into x minus 15 less than 0 or more than 0, whatever. Suppose I'm taking equal to also. Okay. First 3 steps are sorted, you can check. RH is 0, left hand side factorized form, there is all product or division only. Coefficient of x is positive throughout. Plot the roots. Every term will be equated to 0 while plotting the roots. So -9, -1, 6, 12, 15. Same thing then plus, minus, plus, minus, plus, minus. I want less than 0 means this and this. While how will I write x? Because it is equal to here. So everybody will also write equal to here also. X less than or equal to -9 or x will be between -1 and 6 or x will be yes between 12 and 15 both inclusive. Now one more thing to be noted here, friends. Equal to 0, whenever a fraction is equal to 0, what do you feel? There's only one reason, right? That is the numerator is 0. Of course denominator can never be 0, otherwise it won't be defined, isn't it? So same thing for equality. When you're thinking about equality, only the numerator can be 0. Denominator cannot be 0. Means you can't put equal to sign here 12 and add x equal to 12. Denominator will become 0. So it will become undefined. Same for 15. So here you should write like this. So just be careful. Don't just put equal to sign blindly everywhere. Exclude the equal to sign from the denominator roots. Okay. That's it. All right, so this much is fair enough. Okay. Linear, quadratic, and higher order with the help of wavy curve method. Make sure you understand these things properly. Go through it again and again till that you are comfortable. Okay, then we'll solve more and more questions. Thank you so much.